Hello, in this video tutorial we will learn how to program a digital output to follow a digital input. The digital input will consist of a push button, and the digital output will be an RGB LED. Both of them have their connections displayed on the virtual classroom's web page. The digital input through a push button is again a voltage divider with a resistor connected to ground and the push button connected to the 5 volts. Well, the input wire will go into pin number 3 of the Arduino board, and so once we get it connected, the first thing we will do is to check that the reading of this digital input is actually perceived by the Arduino board. So let's say we got our Arduino connected, and then in the Arduino block we got this digital reading. We can pick which pin is it. We have chosen number 3, and now by checking this checkbox the reading will appear on the screen over there. So there we got sprite digital reading 3 false. False means 0 volts are getting into the Arduino board through pin number 3. False so means that the state of the digital input is low. Why is it so? Because we are using a normally open kind of push button. This normally open push button will have the circuit open if you are not pushing actively on it. As we have the wire into the Arduino board going from the connecting point and the push button and the resistor is connected to ground, the circuit to 5 volts is open if you are not pushing the button, and you get the wire going into pin number 3 connected to ground. Now when you push on the normally open push button, then the circuit closes to 5 volts, and then 5 volts are connected to pin number 3 in the Arduino board, and the state will change to high, so showing a true signal on the screen. Let's push the button and check that it changes to the green true, and when I release the finger it goes back to the red false. Digital input can only have one of either two states. The names of the states: high, low, 1, 0, true, false, 5 volts, 0 volts, depend on the context, but they are just the same. The idea is you either have the wire going into the Arduino connected to the 5 volts and then it's true, 1 or high, or you may have your Arduino pin connected through a wire to ground and then you got 0 volts, low or false. Now that we have checked that this digital reading is actually working, we will set the digital output. So this part, the digital reading, constitutes the digital input. Now for the digital output consists in getting either 5 volts or 0 volts out of a pin in the Arduino board. So we are going to set a digital pin, and we will choose it to be number let's say 8 to high. And now when we click on it, if we have the positive side of the red terminal in our RGB LED connected through a wire to pin number 8 on the Arduino board, when we click here, the LED should be shining red. Now we can duplicate this and change the state of the digital pin to low, like that. This red cross means low or 0 volts, so if we click there, we will be sending 0 volts to the positive side of the red RGB LED, and so we will be turning it off. Now, if we want the LED to actually blink, we need to first turn it on, and after that keep it on for some time, and then turn it off and keep it off for some time. Keeping something on or off for some time can be done with the control command wait. 1 second is maybe too long. We may have it like a couple of tenths of a second. Now if we put them together and we click on it, it will blink for 2/10 of a second and stay off. Now we can make this blink anytime we push the pass button, but then it won't be so different from having the LED connected to the power through the pass button. So to show the possibilities of programming the board, we will program an SOS distress signal to be displayed twice every time we push the button. An SOS in Morse code will be 3 short blinks followed by 3 long ones and another 3 short ones. The 3 shorts makes the S, the 3 longs make the O. So now we got 1 short blink here, that would be an S if it repeats 3 times. So we go into the control group and choose the repeat block and make it 3 times. So now this is just 3 blinks, 3 short ones. Now we can separate this letter from the O, from the following one with a wait. Let's have a second, and then we can repeat the group for the S and just make it last longer. So we have an O. Now we have an S, an O, and if we duplicate the S, we will have the other S. Let's place the waiting in between letters there, between the O and the S. So now this will be an SOS. Okay, now we want it to happen twice. So let's make it with a repeat block and place all of this, the S, the waiting, the O, the waiting, and the S inside the repeat twice. So now this is going to be the answer to a digital input when we push the button. So this composite digital output will happen only when the digital input gets a high signal. So how do we check that? We check that with a conditional command with an if. So if, and then we go back to the Arduino block and get our digital reading. If the digital reading in pin 3 is, and that's in operators, equals the state high, which here is depicted as a green true. So, as I was saying, if digital reading in 3 is true, then produce the 2 SOSs, like that. Now, for this to happen, we don't want it to be, we don't want the push button to be checked just once. We want it to be checked continuously. And then that will happen if we got it inside a forever loop. So the conditional if is inside a forever, so when it finishes checking, it checks again. Now let's make this forever happen when we click the green flag and things start. So now when we click the green flag, it will be checking if we push the button, changing the digital input to true, and if it is so, then it will make 2 distress signals with the red LED, like that. Now if we were to use the 3 colors in our LED, then we would like it to be turned on and off first. Let's say first one color, then another, and then another. So how about if we tell apart the first time we press the push button from the second and the third and the following ones, so each time we press our push button a different colors is shining, doing the SOS distress signal, starting with the red and then the green and then the blue and again. So for that we need this number here, number 8, in the digital pin in our output to change it. And the easiest way to make it change is make it change to the next one and the next one. So we should connect the different terminals, the red, green and blue terminals in our RGB LED to pins 8, 9 and 10, and create a variable so the number can change. So we're making a variable and we'll call it color, and then the first value for the variable when everything starts will be 7. Why 7? Because we are going to increase it with change by 1 anytime we push the button. So if color is 7 when the program starts and it changes by 1, meaning its value is increased by 1 unit each time we press the button, the first time we press the button color will be 8, as there. Now instead of having the number, we put the variable, and as we have seen, the first time we push the button this variable will have the value 8. The second time we push the button, which will happen after the distress signal has been played a couple of times, the next time we push the button color will be increased again by 1, meaning instead of number 8 it will have number 9, and the third time it will have number 10. So the digital pin being changed to high and low will be the first time we push the button the 8, the second time the 9, and the third time the 10. If we got red, green and blue terminals connected to 8, 9 and 10, we will have SOSs in red, green and blue. So when we click the green arrow, the color goes to 7. The first time we push the button, color goes to 8. Then after the SOS has been displayed, if we push the button again, color goes to 9 when the digital reading changes to true, and after that when we push it again it will go to 10. Now what happens if we push it again? It will go to 11, but we don't have any RGB terminal connected to 11. We would like it to be 8 again, so it loops through the 3 colors. It loops through pins 8, 9, 10, and then instead of 11, 8 again. How can we do that? We can do that with a conditional. We can say if the variable color gets to 11, so if color equals 11, then what? Then we want it to be 8, so we set color to 8. That only happens when it is 11. So in this case, when color gets to 8 and then 9 and then 10, when it gets to 11 it will change back to 8, so after the blue the red will go back. Well, it's still not finished the SOS. Now 10, we wait for the SOSs to be displayed, and then when we click it again it will go back to 8. And that's it. So now in this way we got a variable in our digital pin that changes to change the terminal that is activated in the RGB. We got a condition so it looped through 8 to 10 and back. And then there's still one more thing we can include, which is just to put some sound through the buzzer. The buzzer will be connected to a fixed pin, let's say 11. We just have to put it on whenever the lights are on, and